Proof, but just an idea of how they came up with the different theory. All right. I like to call them a geometric proof. So the first theorem that you need to know is that angle in a semicircle is 90 degrees. What that means is the angle in a semicircle is 90 degrees. This angle right here so is always 90. You might ask yourself, why is that angle 90, right? Another ways of rephrasing this is to say the angle subtended by the diameter is 90. Another way of saying this theorem is the angle subtended by the diameter is 90. Angle formed by diameter is 90 degrees. Alright, let me try and space this out just a little bit. Angle formed by diameter is 90. That's what we're saying for the first one. So I'm going to put it up here. Angle formed by the diameter is 90. Now look what I'm going to show you. I'm going to bring it to Geometer Sketchpad and I'm going to draw a circle. I'm just going to make a random circle. Let's say with a radius 5. I make this random circle cool. And if I were to just draw the diameter of the diameter of the circle would be from one end passing through the center to the next end. This is a diameter. Now, if I were to draw any random chord, look at this, I'm just going to draw a chord here. And then I'm going to connect this chord back to here, right? Then what we're saying is that this angle is supposed to be 90. Angle subtended by the diameter is 90. Now, let us check it out. Doom, doom, doom. Let's measure that angle. Measure the angle. Oh my God, it's 90. Angle subtended by the diameter is 90. No matter where we move it on the circle, the angle is 90, no matter where we move it. Because why? Angle subtended by the diameter is 90. The angle is not going to change, all right? It's just not going to change. It's not going to change. See there? You can spin it around. It not going to change. It does not going to change. Yeah? Because angle subtended by the diameter is 90. So that's the first theorem that we must know, this one. The next one is that angle at the center is twice the size of the angle of the circumference when they're subtended by the same chord. Subtended just means formed by the same chord. If you're to check it out, I'm going to show you in the Geometer Sketchpad, not on the whiteboard. So let's ignore this for a minute. Let's hide these. Now the second one is angle at the center is twice the size of the angle of the circumference. Everybody know this one, so I don't need to do a proof of it. I can, but we don't need to do this one. Everybody know this one. So these are the popular ones that people generally forget. This one now. Angles in the same segment from a common chord are equal. So if they have a common chord, angles in the same segment are equal. You might ask, why are they equal? They're equal because they are similar triangles. They're similar triangles. They're similar triangles. You see this triangle right here, so? If I were to highlight it, you see this triangle right here. They're subtended by the same chord. This chord down here. This triangle is similar to this triangle. What does that mean? That means that a 32 here equal a 32 here. That means you see this angle right here, so? If this is x, then the angle over here, so, would also be x. Yeah? Because angles in the same segment are equal. Yeah, man. So in the triangle in red right here, so if this are x in the blue triangle, then this are also x in the red triangle. If this are 32, this are 32. Yeah? Whatever is this angle, let me see. Whatever is, I have this angle here, this angle here. Whatever is this small piece in this triangle, it would be this small piece down here in this triangle in the red right there. That's because these two triangles are similar triangles. Similar triangles. If I were to take them out, right? If I were to take them out, this is the one in blue right here. I'm just giving you a representation of what's happening. This is the one in blue right here, right? And this have an angle at 32. The one in red is the same thing, you know, it's just that it in the opposite orientation. The one in red, if I were to put one in red, the one in red is just the opposite orientation, looking like something like this. But a similar triangle there. Two are the same thing, just in a different orientation. That's why when angle in the same segment, they are equal once they're subtended or formed from the common chord. So you must remember this one very popular. This one easy to remember, people normally remember it. Opposite angles in a cyclic quad sum to 180. We usually remember that. The angle between the radius and the tangent is 90 degrees. Now, when you do pure mathematics, you're going to see a lot more with this. You learn that the tangent and what they call this line right here is the normal in pure math. You're going to learn that the normal and the tangent are perpendicular. So just a quick schematic of it. If I were to draw a circle, right? This is a circle right here. And if I were to draw a tangent to this circle, just to show you a schematic of what going on. So I can put this right here. Just to put that right here, so. All right, I'm just gonna draw a tangent at this point. If I were to draw a tangent at this point right here, this is not 100% accurate. I really wanted it to be, but it's not. This is roughly a tangent, right? If this is a tangent, right? We say that the angle between the tangent and the line connecting the center of the circle to the point of tangency, we say the angle between them is 90. May I go verify it? So look at this. If I measure the angle in between this, we're supposed to get 90. So measure, I get 89. I get 90 because my tangent not 100% accurate, but this right here is indeed 90, right? Because my sketch not accurate. That angle right there, so is 90. Yeah, man. That's because angle between the tangent, this is a tangent T, and this line, they call this line the normal, right? They call that line the normal. Any line that connects the point of tangent to the radius is known as the normal. And the normal is perpendicular to the tangent, and so the angle between the tangent and the normal is 90 degrees. Cool. Everybody normally know this theorem. Angles in alternate segment are equal. So if this is 70 and it's subtended by the same chord up here, then this angle is also 70. Angle between the tangent and a chord is equal to the angle subtended by the chord, 60. Everybody usually remember that one. Here's another one that we don't normally remember, and that one is that two tangents drawn from a circle from the same point will be equal in length. Two tangents drawn from a single external point. What does that mean? That means that let's remove all of these, right? So let's remove up all of them here for now, all right? That's our point B. Let's remove B for a second, all right? Now look at this now. If we were to put some external point out here and to try to draw a tangent from this point to the circle, right? Let's say it touched the circle. Where does it touch the circle? It touched the circle somewhere about right here, right? So let's put the point right there. So let's put the point, let's say it touched the circle right here, right? That's where it touched the circle. So let's label this point C, that's the external point, and let's label this point D, all right? And look at this now. If you're to see where this tangent meets the circle at the next point somewhere up here, right? It meets somewhere about right here. Remember, mine is not 100% accurate. It meets somewhere right here, all right? Or we can call that point E. If you were to actually measure the distance CE and CD, check this out. If I measure this distance from C to E, if I measure that distance, I get 11. If I measure D, C, D right here, if I measure this distance, I'm supposed to get 11 too. I might not get 11 flat, but I'm going to get 11. All right, see it there? And the reason being is because two tangents drawn from a single external point, they are equal in length. I don't get them exactly equal because my tangents, they're not 100% perfect. That's all that rule is saying for circle theory. All right. This one said the radius through the midpoint of a chord will bisect at 90 degrees. And there's one more rule that we need to remember, which is that two tangents drawn from a single external point and two radii will always form a cyclic quadrilateral. All right, two tangents drawn from a single external point and two radii will always form a cyclic quadrilateral. And that's all the rules of circle theorem. So now, as we discussed all the rules, we're going to just go through some questions now, which is what I know most of us want to see, doing some questions. So let's take on some questions now. Very easy worksheet. All right, so it says, in the diagram below, points Q and S lie on a circle with center O. SR is a tangent to the circle at S. Angle QRS equal 40 degrees and angle SOQ equal 80 degrees. Prove that QSR is isosceles. Now QSR, now just want to show you what triangle that is. QSR. We need to prove that this triangle is isosceles. All right, we need to prove this triangle is isosceles. This triangle is isosceles if it has two sides being equal in length and therefore two sides being equal in angle. Now, the first thing we know is that OS is a radius and OQ is also a radius. So then what do we know? What we know then is that since OS and OQ are both radii, since OS and OQ, are both radii, then we know that the angle that would be OQS, then angle OQS is equal to angle SQO. Yeah, man, since they're both radii, we know those two angles are equal. All right, these two angles are equal. So let me just move this up here so it's not too disturbing. All right. So we know that since OS and OQ are both radii, this angle right here, so, is equal to this angle right here, so, because this is an isosceles. This is a radius, this is a radius. This angle is 80 degrees, so therefore this angle and this angle right here are both equal. So to find these two angles, you can call it x. Then this angle is also x. So what we then know is that 2x plus 80 is 180 because angle is in a triangle sum to 180. 2x plus 80 equal 180. So then what we know is that 2x is equal to 100 and so x equal 50 degrees, right? So therefore we can write down right here, so now that this angle in here so is 50 degrees and this angle up here so is 50 degrees. All right. Now to prove that this triangle is isosceles, we need to show that this angle in here is 40. Because if this angle in here is 40 and this angle in here is 40, then they have two equal angles, then that would mean that they also have two equal side lengths being equal. So now how we're going to show that this angle is 40. Now we have to remember the rule that says angle between a tangent and a radius is 90. See here, let's go back to the theorems. Angle between a tangent and radius is 90. So that's what we're going to do right here. So angle between the tangent, this tangent which is SR, and the radius OS, that angle is 90. Since the whole of this is 90 and this piece over here is 50, then this side right here, this little piece, I'm gonna put it in a better, this little piece that I shade, that part is 40. This part has to be 40. All right, in order for the two angle them sum to 90. Now, if this angle now is 40, then what we can conclude is that this side, we can tell them that QS is equal to QR since angle QSR is equal to angle QRS. So let's write all of that in words now. Let me show you how you would write it up in words. Because it's very good that we always write up the thing then in words. So we can tell them that in triangle, what was it again? In triangle OQS, in triangle OQS, OS and OQ are both radii to the circle. Hence, angle, it was angle SQO and angle O, what was it again? SQO, angle SQO and angle QO and angle OSQ and angle OSQ are equal and both being 50 degrees since angles in a triangle sum to 180. All right, so that's the first part. So nice. Now after you tell them all of that now, we can tell them also angle between a tangent, in this case, the tangent was SR, angle between a tangent SR and the radius OS is 90 degrees. So you can tell them angle, hence you can tell them that, you see this angle right here, hence angle OSQ plus angle QSR equal 90. And angle OSQ plus angle QSR equal 90 degrees. That's what you tell them. Then you tell them now, but remember, watch this now. We said that angle QSR, right? Angle OSQ and angle QSR. But we already have angle OSQ. Angle OSQ was 50. So you tell them, hence, angle QSR is equal to 90 minus 50, which is equal to 40 degrees. Putting it in words, that's how we get the 40 degrees right here. And then this angle is 40 degrees and this angle is 40 degrees. You can tell them now, since angle QSR is equal to angle QRS, therefore QS is equal to QR. So I'm just going to put that right here. You tell them, let's put it in a smaller font. you tell them since angle QSR is equal to angle QRS, which is equal to 40 degrees. Hence you're telling them the length QS is equal to the length of QR, and so triangle QSR is isosceles. That's if you were to write out the reason. I did send to put reason, but this is if you were to write out everything in words. You start from up here, here, and here. Or in other words, you write all of this, and then you finish off with this. All right, let's look at the next one now. The next one says A, B, and C are points on the circumference of a circle with center O. It says BD and CD are tangents. It says angle BDC is 40. Work out the value of P. Now, two tangents and two radii will always form a cyclic quadrilateral. Two tangents and two radii will always form a cyclic quadrilateral. You have to remember that. So let me show you the cyclic quad we're talking about. This right here, yeah man, this, them there are radii. This right here, tangent at C, tangent at B. All right, so you can tell them that two tangents and two radii always form a cyclic quad. Two tangents, can put in bracket, in this case, BD and CD and two radii. In bracket, you can put in BC and DBC, not BC, OB, sorry. Radii are OB and OC. Two tangents and two radii will form a cyclic quadrilateral, cyclic quad. And so, what do we know about cyclic quad? Opposite angles in a cyclic quad sum to 180. And so, that means that P plus 40 is equal to 180. And so, that means that P is equal to 180. And so you can tell them now, hence, P equal 140. All right, because opposite angles in a cyclic quad sum to 180. Just to show you about that rule, see it here, opposite angles in a cyclic quad sum to 180. Opposite angles in a cyclic quad always add up to 180. All right, nice. Now it says, hence write down the value of Q. Angle at the center is twice the size angle of the circumference, and so Q is equal to 70 degrees. Why is Q equal to 70 degrees? Angle at the center, half the angle at the circumference. I'm just writing it out in words here proper. Angle at the center is half angle at circumference. That's the rule that we use for that one. Angle at the center, half the angle at the circumference. Nice. Now this question right here says, the tangent TB, DB is extended to T. The line AO is added to the diagram. Angle TBA is 62 degrees. And it says work out the value of X and then work out Y. Okay, now let's look closely at what we have right here. Right here we have a tangent. This is a tangent TD and this is a tangent CD. All right, so it's a cyclic quad. All right, what do they want? They want the angle at X. Ah, so this is where we come. Angle between a tangent and a radius is 90. So that angle between the tangent and the radius is 90. This angle right here is always 90. Angle between the tangent and the radius is 90. Since the angle between the tangent and the radius is 90, and that stems from this theorem right here again, angle between tangent and radius. Since that is 90, we know that the angle 62 plus something right here, so we don't know what this little something is. This little something right here, so we need to find it. All right. So we know that 62 plus that angle is angle ABO plus angle ABO. We know say that equal to 90, and that is put in bracket since angle between tangent and radius is 90. All right. So therefore, we can tell them that angle ABO equal 90 degrees minus 62, which is 28 degrees. All right. That's 28 degrees. All right. Nice. Angle. Now, since angle ABO is equal to 28 degrees, that implies, let's just put this symbol, that implies that angle BAO, that implies angle BAO equal to, that will also be 28 degrees. Why? It will be 28 degrees since AB, since AO, sorry, and BO are both radii, So ABO is isosceles. Yeah, man, that's what you have to put. You have to tell them that that is an isosceles triangle. This is an isosceles triangle. We were to continue. This is isosceles because AO and BO are both radii to the circle. Then now angles in a triangle sum to 180. Angles in a triangle sum to 180. And so that means that x is equal to 180 minus 2 times the other two angles them, which is 28. Now, can't bother work that out. We're just going to put that in the calculator. All right, I know it sounds really, really, really lazy, but just one of those things. So let's put it in the calculator. All right, 180 minus 2 times, that's 28. And we're supposed to get 124. So this equal to 124 degrees. That is x, 124. All right. Now that we get x now, I know that x is 124. What else do we know now? We know that since x is 124, we need the value of y. So y is in this triangle right here. Now, since we're in this triangle, we need to find this angle first. And how can we find this angle? Look at this now. The same rule we just talked about up there. Two tangents and two radii will always form a cyclic quad. So I'm going to put the cyclic quad in blue. This right here, this right here, this right here, this right here forms a cyclic quadrilateral. Since that part forms a cyclic quadrilateral, the angle inside here then is going to be 140. So x is 124 and this is 140. Now, since this angle is 140, angles around a point sum to 360. Angles around a point sum to 360. So let's write that down. Angles around a point are angles in a circle. So this whole thing, remember, is 360. Yeah, this whole thing is 360. All right, so you can tell them that B D O C forms a cyclic chord. Since it forms a cyclic chord, we can tell them so angle BOC, we can tell them then that that is equal to 140 degrees. All right, and then now we know that angles around a point sum to 360, so you can tell them 124 plus 140 plus this is angle AOC, that's supposed to equal to 360. So what is AOC? We subtract them from 360. Let's go ahead and do that. 360 minus, this is put in bracket 124 plus this is 140. We close that bracket, we end up getting 96. So the angle at O is 96 degrees. So we can tell them so angle AOC equal 96 degrees. So let's put that on the diagram. I'm going to put it in red. This angle right here is 96 degrees. Now, since this angle is 96 degrees, this angle over here is also y, because it's isosceles. This is an isosceles triangle. Why is it an isosceles? Because AC is a radii or a radius, and OC is also a radius. So we can work it out now. Let's finish it off right here. And so we know that angles in a triangle is 180. And so we know that 180 plus, well, we can just say 180. So 2y plus 96 equal 180. And so you can subtract 96 from both sides. I'm going to just put it in the calculator. 180 minus 96. And then you divide that by 2. So that is y. Y is 42. So we can write that down. And so y is equal to 42 degrees. If you want to put the reasons again, you have to tell them that you have to tell them triangle AOC is isosceles, since you can tell them that AO is equal to OC because they're both radii. So that was the reason. And then you can tell them angles in a triangle sum to 180. Nice. All right, looking at this question right here. It says A, B, C, D are points on a circumference, and it says AC is a diameter. Now clearly, if AC is a diameter, it's done already. Angle, look at this. AC is a diameter, so it's done already. Angle subtended by the diameter formed by the chord is 90. So if AC is a diameter, this is 90 degrees. This is rule number 1. Let's go back to the rule. Number 1. Angle in a semicircle is 90. And we rephrased it to say angle formed by the diameter is 90 degrees. So this angle clearly is 90 degrees. All right. So since it's a semicircle, if you want to write reason, right, you're gonna tell them that angle ABC equal 90 degrees. Why is it equal to 90 degrees? Angle in a semicircle is 90, or angle formed by the diameter. Why am I putting it in caps? Angle subtended by the diameter is 90 degrees. Right? And the diameter we're talking about is AC. All right. And so what you end up getting now is to find the angle y. We know that angles in a triangle sum to 180. So y, we should have find x first. My apologies, I'm finding y first, but no worries. I didn't read the question properly, but 65 plus 90 plus y is equal to 180. And so now we can find y by subbing. So putting it in the calculator, we just go 180 minus 65 minus 90. And so y is 25. So we can write that down. So y is equal to 25 degrees. Now the next thing it said is that we need to write down the value of x. Now angles in the same segment subtended by the same chord are equal. And so if this angle right here is 65, then clearly x is also 65 degrees. That's because angles in the same segment are angles subtended by the same chord. Angles that are in the same segment subtended by the same chord are equal. Angles in the same segment from a common chord are equal. See that 32, 32. This would have been the same. This would have been the same. Same thing right here. So now this and this equal. The common chord is BC. All right. So that's it. Easy, soft, 65 degrees. Nice. Now this question right here says PQRS, line a circle. PQ is equal to QR, and then tell us the angle PQR is 116. Now the first thing is, since these two sides are equal, this is isosceles. So before you even start the question, you know, so this is isosceles. Since that is isosceles, that will be key to helping you to answer this question. So even before we do it, we know that angle QPR, this angle right here, is equal to angle QRP, this angle right here, right? If you want to call them X, whatever, let's call it X, just for easy referencing. Let's say you want to call it X. So X plus 116 equal 180, right? So you can write it down right here, that X plus 116 equal to 180. So that is really 2x plus 116 equal 180. So that's really saying 2x is 180 minus 116, which is 64. So x equal 32 degrees. Now, the reason again is because QPR is isosceles. That's to put it in short. This is an isosceles triangle. I know isosceles triangle have two equal angles. Good. Now, we need to find angle QSR. Q, QSR. So this is the angle you want to find. QSR, the angle at S in this triangle. Now, look at this. Angle, angle angle RPQ is equal to angle RSQ. That's because angles in the same segment are equal when they're formed by the common chord QR. So we're done. So we can just write that down. We can tell them, say, angle QSR is equal to 32 degrees since angle QSR is equal to angle RPQ. And that is since angles in the same segment subtended by a common chord are equal. That's it. Easy, soft. That's the reason. All right, nice. Now let's look at this one right here. It says the diagram shows a circle with center O, and it says the tangent TA to the circle is at A, and it says angle BAC is 58. Angle BAT is 74. And it says calculate angle BOC. Okay, we need to calculate angle BOC. That is this angle right here. All right. All right, now let's not look at this now. Do they have the common chord? BAC common chord. BCO, yes, and the common chord is BC. So angle at the center is twice the size. We're good already. So we can tell them that angle BOC, you can put so that is equal to 2 times 58 degrees, which is 160 degrees. And that is because angle at the center, remember, angle at the center is twice the size, the angle at the circumference. All right, so cool with that now. Now it says find angle OCA. Now we need, this is 116, all right? Now we need angle OCA. Angle OCA is this little piece right here. So let's see how we can get that piece right there. So now since we know this angle, we can find this angle and this angle because BOC is isosceles, right? So we can tell them that triangle BOC is isosceles. I maybe not spell it right, but if that's fine, BOC is isosceles. Since it is isosceles, we know that angle OBC is equal to angle, that's gonna be, it's equal to angle OCB, and the two of them, they equal. I'm just gonna put it in the calculator. 180 minus 2 times, well, 180 minus 116, and then divide that by 2, that's 32. So both of those are equal to 32 degrees. All right, both of those are equal to 32 degrees. So you can put that down. This up here is 32. This right here is 32 degrees. All right. Now, let's see now. That still doesn't help us because we need angle OCA. But what do we know? We know that angle between a tangent and a chord is equal to angle subtended by the chord. Ah, we're good now. We're really good now. Angle between a tangent and a chord is equal to angle subtended by the chord. Let me put the chord and the tangent we're talking about. This is the chord and this is the tangent. An angle between this tangent and that chord, so this angle that I'm going to shade in black, that angle right there, is going to be equal to this angle right here. So now you can find OCA. So now we can write down that angle OCA, I'm just going to write OCA due to limited space. We can just write OCA plus the 32 must equal to 74. And so angle OCA is equal to 74 minus 32. You put that in a calculator. 74 minus 32, and that is 42 degrees. So you can tell them, say, that equal 42 degrees. What is the reason? Again, it is because angle between tangent and chord is equal to angle subtended by chord. Angle between tangent, you can tell them what the tangent is, TA. Angle between tangent and chord is equal to angle subtended by the chord. And the chord that we're talking about is AC. That's it. All right, let's move it over a little bit. Yeah, man, we're cool. Nice. All right, this one right here now says, write down the angle x. Angle at the center is twice the size angle at the circumference. X equal 100 degrees. There's no issue with that one at all. Oh, good. Nice. All right. Now this one says, the diagram shows a different circle with center O. Of course, it's a different circle. It's not the same circle from the previous question. Work out angle y. Opposite angles in a cyclic quad sum to 180. So y plus 50 equal 180. And so y must be 130 degrees. All right. The reason is opposite angles in a cyclic quad sum to 180. Now, there's an important thing to note. It's only a cyclic quad when you have a quadrilateral and the four sides them touch the circle. All right, that's the only time it's a cyclic quad. So a lot of times, person will probably see a quadrilateral inside the circle and think it's a cyclic quad, but it's not a cyclic quad. It's only a cyclic quad when the four sides them touch the circumference them on the circle. All right, just want to clarify that. Now this one says the diagram shows a cyclic quad ABC. The straight lines BA and CD are extended and meet at E. EA is equal to AC. Angle ABC is 3x degrees. Angle ADC is 9x. Angle DAC is 2x. Everything depends on the diagram. Show that x equal 15. All right, let's see how we can do this. Now this is a cyclic quad. This is a cyclic quad A, B, C, D. This forms a cyclic quad. Opposite angles in a cyclic quad sum to 180. So what we can then tell them is that 3x plus 9x is equal to 180. And so if you add them, you get 12x equal 180. So you can tell them x equal 180 divided by 12. 180 divided by 12 is 15. Just to plug it in the calculator, just to show it, 180 divided by 12. I just like to show them thing here, right? Let me make sure everybody is satisfied. 180 divided by 12, 15. So x equals 15 degrees. So good. X is 15. And the reason, you're going to have to tell them that opposite angles in a cyclic quad sum to 180. Oh, good. Next thing is to work out the size of angle EAD. Work out this angle right here, angle EAD. This piece of angle right here. Now, since we know that this is 15, x is 15, we know this angle, all right? And it shows that over here, AC is equal to the length AE. So that will come into play at some point. All right, and we already know 2x. Now look how we're gonna do this. We know this angle, right? We know this angle because triangle ACE is isosceles. All right, so I'm gonna put it out in a different color so we can actually see it. Yeah, man. So see it here, this length equal to this length, right? And so this is isosceles. If this is isosceles, then we can call this angle x right here, not x, it is y. Call this angle y and call this angle y. Don't forget those two angles must be equal since it's isosceles. All right, so you can tell them triangle ACE is isosceles. And so we know that 2x plus 2y equal 180. We already know what x is. X is 15, so 2 times 15 is 30. So 2y is equal to 180 minus 30, which is equal to 150. And so y must be 75. Y is 75. Now, since we just get that this angle right here, so is 75, right? We know that this angle is now 75. Now we need to get this angle, EAD. We need to get this angle right here. Now if this angle, 2x, okay, I think we made a slight error. We needed all of this, right? We needed all of this. Sorry, my mistake. We'll call this y, and this is the angle we want. Yeah, I made a mistake here. Let's rectify this mistake right here. Let's rectify this. My sincere apologies. All right, moving a little too fast here. If we call this y, we'll call this y. This is the angle we want, right? This angle right here, right? This angle is what we want right here. All right. This angle right here we want. Let's call it z for now. My sincere apologies. Now what we're going to do now is look in this triangle, sorry, to find y. You have 9x, 2x, and y. So what you'd say is in triangle, that looks like ACD, in triangle ACD, the 9x plus the 2x plus the y equal 180. So that means that 11x plus y equal 180, but we already know what x is. So y is equal to 180 minus 11x. And so that means y equal 180 minus 11 times 15. You punch that in your calculator. 180 minus 11 times 15. And you work that out, you get 15 degrees. So y is also 15 degrees. All right, y is 15 degrees. Now, since y is 15 degrees, this right here is a 15, then this right here is also 15. Yeah, we're good now. Since this is 15, this is 15, and this is 2x plus z, we can tell them now in triangle ACE, in triangle ACE, we know that 15 plus the 15 plus the 2x, which is 2 times 15, plus z, where z is angle EAD, which is what we want. We know them sum to 180. Nice. Yeah, man. We know it's sum to 180. So good. All right. Well, good. Nice. Now that we know that now, let's see how we can transpose now. So transposing, what we're going to get is angle EAD is equal to 180 minus 15 plus 15 is 30, plus 2 times 15 is another 30. 30 plus 30 is 60. So we subtract them now. Is that 120? I'm just making sure. I don't know why I didn't use the calculator, but I'm getting 120 degrees. All right, nice. So that is it, 120. So 120, the 30, the 15, and the 15, we're good. All right, oh, nice. Yeah, man, that's it. Easy, soft. All right, let us look at this question now. Write down the value of x. Angles in the same segment are equal when subtended by the same chord. X equal 40 degrees. No issues. All right, and that's because angles in the same segment are equal. There's nothing to that, see it here. Then finally, y equal 140 opposite angles in a cyclic quad sum to 180. So you can tell them y equal 140 degrees. All right, nice. This never have nothing to do. All right, moving along. This question right here says A and C are points on the circumference of a circle, center B. AD and CD are tangents and angle ADB is 40. ADB is 40. Explain why angle ABC is 100. Angle ABC. Angle ABC is 100. Now this right here is 100. Let's show them why. Now first thing is that if this is at two tangents drawn from a single external point are equal in length. Two tangents drawn from a single external point are equal in length. So we can tell them first thing, say AD is equal to BC. See it here, two tangents drawn from a single external point are equal in length. The tangents to a circle from the same point will be equal in length. DC is equal to EC. See the little line there? Good. So now since AD is equal to BC, because two tangents from a single external point are equal in length, hence we know that angle ADB is going to be equal to angle, it's going to be equal to angle BDC. Yeah man, it's going to be equal to angle BDC. And both of them equal 40 degrees. All right, cool. So that means that we can put this on now and say this part right here, so equal to 40 degrees. Now you have AD is a tangent, CD is a tangent, AB is a radius, BC is a radius. Two tangents and two radii always form a cyclic quad. So two tangents and two radii form a cyclic quad. Two tangents and two radii form a cyclic quad. Since it forms a cyclic quad, what do we know? 40 plus 40 plus angle ABC equal 180. And so ABC is 180 minus 2 times 40. And so angle ABC is equal to 100. That's your reasoning. All right, so we give them the reason and we're good. Nice. Easy. You right for them question here? Soft. Nice. All right, this last one now. This last one says ABCD is a cyclic quadrilateral. PAQ is a tangent to the circle. BC is equal to CD. AD is parallel to BC. Angle BAQ is 32. Find the size of BAD. So they save the best one for the last one. Angle BAD. BAD. So just making sure this is the angle they want us to find. All right. Now the first thing we know is that angle between a tangent and a chord is equal to angle subtended or formed by the chord. Right? That's the first thing that we know. Angle between the tangent and the chord is equal to angle formed by the chord. So that's telling us that this angle, let's see, just for the common chord, all right, so as we were saying, this right here is the tangent. All right, this right here is a tangent, and we have the chord. All right, so we know that angle between tangent and a chord is equal to Angle between a tangent and a chord is equal to the opposite angle in the next triangle subtended by the same chord. So this tangent, this chord, subtend this chord. So they're telling us that this angle is 32, which must be equal to this angle, right? So we know that this angle is 32. And so clearly this angle must also equal to 32. Yeah, let's write that down. So writing that down, we know that angle, we know that angle CDB is equal to angle that is CBD, which both equal to 32 degrees, since angle between tangent and chord is equal to opposite angles subtended by the chord in the triangle. All right. And so now what do we know? If this angle is 32 and this angle is 32, then this angle up here we can find, because angles in a triangle sum to 180. So then we can tell them that angle, that is angle DCB is equal to 180 minus 2 times 32, which is 180, minus 64, which is 116 degrees. All right, and that's because angles in a triangle sum to 180 degrees. Then finally, we need angle BAD. So we need the angle in here. That's what we had said. Now, now we know that DCBA forms a cyclic quad. So you can tell them that DABD forms a cyclic quad, and so angle BAD plus 116 is equal to 180. But that's because opposite angles in a cyclic quad sum to 180, and so angle BAD is equal to 180 minus 116, which is equal to 64 degrees. That's it. Easy, soft, nice. So finish circle theorem. This is just a run through. I really hope this video would have helped many persons with circle theory. I know it's a weak topic, and I just wish you all the best practicing for your exam. Make sure to go through all of these theorems and know them by heart. Know all of them. Angle in the circle, semicircle is 90. Angle at the center is twice the size. Angle at the circumference. Angles in the same segment. Alternate segment theorem. Opposite angles in cyclic quad. Two tangents and two radii forms a cyclic quad. Two tangents joined from a single external point are equal in length. Angle between radius and tangent is 90. Know all of them. All right. Make sure to subscribe to help the channel grow, and I wish you all the best prepping for your exam.